Attributes need to be tuned. Only then we can have path as per our policy. How do we do that? How do we tune it? How do we manipulate the BGP path? Using route map is one option. Using route map is more granular than without using route map. Yes, you can tune attribute without route map. But with route map you can do more granular tuning, more precise tuning. What do I mean by that? More granular, more precise. Let's see some example, then you will understand. This is explaining the requirement. This is explaining that we have policies. This picture explains that what sort of policy we need between the autonomous system. From A towards X, you want to send 60% of traffic to the limit of 60% of bandwidth. On that same link, the incoming should not be more than 10% of bandwidth utilization. From B, you have another policy, different policy, not the same like A. From B, what do you have? I want to use 75% of bandwidth of the link for incoming, but for outgoing it is only 20. You see? So we have policy, outgoing, incoming. We have policies. This is just to explain you that we have policy, this kind of policy. Now let's see some example. Before that, this is what I was telling you. You can configure attribute without route map. See this example here. We go under router mode and say BGP default local preference value. What is the default local preference value? 100. If I give a higher number on this router, then this router will be a preferred exit for all inside the autonomous system. See, for any destination from your autonomous system, this router will become the exit for any destination. You remember that picture that we had yesterday? Router A, router B, router C. This is connecting to Orido, Orido. That's one ISP. Orido. And there is another ISP. Etisalat. Now when I go here and put this command with 400, every router will take Orido. We'll use Orido as the ISP to go online, not Etisalat. Etisalat is another ISP. In Dubai you can see both. Now, is this granular? Is this precise for some destination, for a particular destination? No. For any destination in the internet, A will be the exit. Any destination. You may be going to YouTube, you may be going to some your office web server, wherever. Router A will be the exit. But this is without using route map. This is for all the destinations, which you can also go via B, but you have set 400 on A. As a result, all traffic to any destination leaves out from A towards Orido. This is not granular, this is for all destinations. Now we are going to see this case study to understand that we need a route map to have more effective path selection, more accurate, more granular, more precise path selection. With this case study, we will understand that this is not enough. Without route map is not enough. In the real world, you will have something like this. We need route map. See, what is a route map? A map for routing. More about route map is coming. Let me first go through this, walk you through this case study, and then I'll show you an example of route map and explain you route map. All of you see this picture closely. See, 170 to 30 goes via Y because it is only two hop, one hop here and one hop here. 170 to 24 is going via Y, it is because only one hop. Now I'm asking 170 to 16. 170 to 1600. What will be the next hop from router C?
190 to 160.
Exactly. X 192, 168, 28.1, because that way it is only two hop. The other way is 1, 2 and 3 hop. Fine. Now you all did a good job. What, Anbu? You all did a good job, Anbu. Now, you see, we are going to go with an assumption now in the next page. This is what you just answered. You said 170 to 16 will go via 190 to 168. Yeah, 170 to 16, 190 to 116. And then 170 to 30, you said it will go via 170 to 20. That is right. And then 170 to 24, you also said it will go via 170 to 20. That is also right. Now the assumption is this. assume that it's not assumption, it may be a real figure in their network, but in your network we have to sit and analyze. See, they have sit and analyze and they have come with some number. They say at a given time 30% of traffic is to this destination. So to this destination it is 30% of traffic, and to this destination 20% of traffic, and to this destination it's 10% of traffic. Okay, so this is it. This is what given to us. You know, someone is sitting and monitoring the traffic and seeing that how many percentage to which destination, and they have come up with this number. They have come up with this number. Now, let's call this as Ethiosalat. This is Orido. Tell me how much traffic is going via Orido. 50%, and it is only 10% going to Ethiosalat. That's what they also said here. 50% of traffic is going to Orido, only 10% is going to Ethiosalat 192.168. Your job is to load share. Make the traffic 170 to 30 to select this next hop. Why? Because 170 to 30 is 20%. If the 20% goes to Ethiosalat, already it is 10% it is taking. Now another 20% if you send, that will become 30%. And to 172, 24 also 30% which is going to Orido already. That way you can load balance. I repeat. As of now, 50% is going to Orido. But when I take 20% of this 50, take it out, and remaining is what? 30%. Take the 20% and give it to the X direction, which is only having 10. So that side also 20, this side also, sorry, that side also 30, this side also 30 now. Hope you understand. I hope you understand now. You take this traffic and send it to X instead of Y. If you do that, 20 plus 10 is 30, and this is also 30. You have load shared. Do you understand what I said?
Yes.
What about others? See, this is just one example. Don't search for this type of real world scenario in your life. Maybe there with the different network. This is just an example to show you how I can use route map with local preference to achieve this. So what I need to do is I simply need to match this 170 to 30, which is 20%. I need to just swap this down here. by giving more local preference. Simple. Local preference comes before AS path. Before AS path comes local preference. So it won't check this one. It will check this. Compared to this, this is bigger. So the greater than symbol will switch here. That's what we are going to achieve. For that, we are going to use a route map. See, listen, this is not for all destination. For all destination, you will simply use this command on router A. For all destination. But in our case, it's not for all destination. Only for those traffic that goes to this one, I want to leave this way instead of leaving this way. Instead of leaving this way, I want to leave this way. Only for this destination. Only for that destination. That's why, precisely, particularly, you need a route map whenever there is something particular, precise, like this. We write an access list first, matching that network that you want to give more local preference on router A, which is here, so that instead of going this way, it should go this way. So you go to this router here and match this network on this router. How do you match? Write an access list and create a route map. Give any name. Name try to give in a capital letter so that you will know that this is not a command. This is a name. So give a name. Even if you don't give permit, it is by default permit. Even if you don't give any number, it is 10. But when you write another route map with the same name, you have to put this number 20, saying this is after that. Now, we have written an access list. We say route map and name. You no need to mention permit. If you mention, it's up to you. It is okay. The default is permit only. Only when I want to deny, I'll mention. Otherwise, I won't mention. In my configurations, I won't mention. But when you go to the running configuration and check, you will see as if I have mentioned it. No, I didn't mention, but it will come automatically if it is permit. For deny, we will mention. Anyway, route map. Give any name. It need not to be a local preference name. Give any name. 10. Even if you don't give 10, enough. No problem. Match IP address the 65. If that match happens, set local preference 400. Now you need to create another route map with the same name and sequence number 20. You have to mention the sequence number. Even if you don't mention permit, it is okay. You need to just create this route map and come out of it. Why did you create this? So that whichever did not match in this access list will be permitted without any change. Hey, it is like an access list. When you write access list, we used to say, no, permit any at the last. Likewise. Those networks that are not matching in this access list, they need to be simply permitted without any modification. Only when it matches this access list, the local preference need to be set. All others should be sent without any alteration. If you forget to give this one, all other networks will not be learnt. Okay, now what is next? Now you go to this SSLAT address, neighbor. This is not SSLAT address, this is your outer edge router. This is your edge router, and you are saying the SSLAT's IP address. SSLAT's IP address is 192.168.20.81. Call the route map that you created and say in. What does that mean? Whenever SSLAT is giving me means what? In. Me means who? A. Router A says giving me. When SSLAT is giving me, when it comes in, look for this update. If this update matches, set 400 and receive. As a result, look at this. Only for that network. Earlier it was here, now it is shifted here. Let me show you. Before configuring, it was here, pointing towards Orido. After configuring, pointing towards SSLAT. Even though, in spite of the big autonomous system path, it goes via SSLAT. The reason is before AS path comes the local preference. Local preference is attribute number 2. AS path is attribute number 4. You see, because we know in sequence, in order, we are able to understand this. If not, very difficult. Very difficult. If someone is asking you, hey, what man? This is just 2 hop and you are going where this way. And then we will blame, yeah. There is one bug, I think, in this operating system, you know. Yeah. It should go this way only. You are right. Why it is going this way? Hey, there is a bug, man. For that to support, there will be 2% there. Same like us. Yeah, it's a bug, man. Just ignore. Let's go next. Okay. So it is local preference. Attribute number 3. Attribute number 1 is, attribute number 2 is local preference. 0th attribute is next hop. Did you understand this case study? And now you see equal amount of traffic is going. 30% of traffic goes to this one is SSLAT. Another 30% goes to this one is Orido. Right, this is an example. We are going to have similar example in our lab. We will test weight and local preference with route map and without route map. Afterwards, we will come back to the same chapter we are. We will continue with the MED after that. First, let us test these things in our lab. So for our lab, our topology is going to be like this. We'll have this topology and we'll discuss various options with different policies. Initially, we'll start with weight with route map, without route map, and then local preference with route map and without route map. Followed by we'll check all other things like MTU, etc. Sorry, multi-exit, MED, origin code, AS prepend, all the stuff. Right? Any question before we close? Anyone has got any question?